Yesterday we talked about how we could use the law of sines to solve a triangle or find the different sides and the different angles in a triangle. Today we're going to look at the law of cosines, which lets us do that as well for those that we can't do with the law of sines. So we're going to learn how to solve a triangle with the law of cosines. So this is the law of cosines. You're going to have to change your diagram on your notes because or just change the labels because I think B and C switched on the side. So just make sure that your C is opposite angle C and side B is opposite angle B. Now this is the law of sines, and there's three different equations, but I just kind of remember it as if I'm going for this angle here, okay, this would be my B squared, this would be my C squared. So we're gonna, this side squared, so I'm going for this side, okay, is equal to the other two sides squared minus 2 times those times cosine A. So it looks big and bad, but once you get some practice, I don't even think about the formulas, I just do it. Okay, so in this case, I've got this angle right here that's opposite C, so that's what I'm going to use. So it's going to be C squared equals, I'm going to do this two sides that make up the angle, plus 15 squared, okay, minus 2 times 17 times 15 times cosine of 87. So I've used the included angle is the one we do the cosine of. So if I simplify this, I'm going to get C squared equal to 289 plus 225 minus what I multiply 2 times 17 times 15 times cosine 87, I'm going to get 26.691 approximately. Now I'm not changing this in my calculator, I'm saving it like I showed you guys yesterday. So now when I do this math, add it up and subtract, I'm going to get 487.309. And then when I take the square root of both sides, so I'm going to take the square root, I'm going to get 22 and 75 thousandths. So C is equal to 22 and 75 thousandths. Okay. Okay. Now when I say to solve a triangle, it means I want to find all of the angles and all of the sides. So in this case, I've got just sides, so I want to find my angles. So I'm going to start, and I'm going to say that this is what I'm going to square, okay? And it doesn't matter which one you pick because you have all of them. So 38.6 squared, and I'm going to call this angle X, so that's what I'm going to find first, is equal to 31.4 squared plus 23.2 squared. So the angle in the two included sides, this is the side opposite the angle that we're looking for, 38.6, okay, minus 31.4 times 23.2 times the cosine of X. I don't like to bring it down to the new line, but I guess I wrote too big. All right, when I square everything, I get 1,489 and 96 hundredths equal to 1,524 and 2 tenths minus 728 and 48 hundredths times the cosine of X. Okay, so I've got to follow rules for solving equations, so I'm going to subtract the 1,524 and 2 tenths from both sides, and it's going to give me negative 34.24 equal to negative 728.48 equals cosine X. I'm going to divide both sides by the negative 728.48 and that will give me approximately 0.047 equal to cosine x. And this time, remember, we've got to use inverse cosine to find x. And in this case, x is approximately 87, and with angles, I'm just going to go out to the nearest hundredth. So this is approximately 87.3. Okay, and now I think that this is a much more difficult formula. It takes much more time, but now I've got a side and an angle opposite it, so I can use law of sines. So I'm going to use a combination of law of sines and law of cosines. So we're going to do the sine of 87.3 over 38.6 equal to the sine of, we're going to call this one b, so this is what we're going to look for, that one, b, over 23.2. And again, remember, it's a proportion, so 23.2 times the sine of 87.3 equals 38.6 times the sine of b. So when I divide, I get 23.2 sine of 87.3 over 38.6 equals the sine of b. And again, I'm going to use that inverse cosine. So the sine of b, if I simplify that, is equal to 0.595. And then b, if I'm using my inverse sine, is equal to 36.5. And then to find my third angle, we use the third angle theorem, and we know that that's going to be 56.2. They all have to add up to 180 degrees. Okay, a lot of work for that problem. All right. Last problem, a racing committee wants to lay out a triangular course with a 40-degree angle between two sides of 3.5 miles and 2.5 miles, and what is the length of the third side? So we're going to make a diagram. I've got a 40-degree angle between sides of 3.5 and 2.5. So I want to know what this side is. So again, I've got my included angles. So x squared is going to equal 3.5 squared plus 2.5 squared minus 2 times 3.5 times 2.5 times the cosine of 40. So I'm going to get x squared to equal 12 and 25 hundredths plus 6 and 25 hundredths minus 13 and 406 thousandths. When I do my math, I get x squared equal to 31 and 906 thousandths. And when I take the square root of both sides, x is equal to approximately 5.649 miles. All right. So those are the law of cosines, and we can use that in a variety of different ways where the law of sines is not going to work. So have a fantastic day.